I have here a Sparkfun RTK GNSS receiver, and I want to show how to do something that I'm not sure is really common knowledge, or even that you can do it. And what I'm going to do is collect data with this thing for post-processing rather than real-time kinematic. So not real-time kinematic, but post-processing kinematic. And that was the traditional way to get accurate GPS. Real-time is a more recent creation, but really what you're doing is you're collecting a log with this, and then you're taking a log from a base station. And here on Maui, we have a base station up on the mountain. Oh well, there's clouds, so you can't see the top of Haleakala, but there's a base station up there. And that base station collects a log as well, and the position of that base station is known. So you take that data from the base station up the mountain or wherever your local one is. You take the log from this, which collects all the signal data from every satellite, and you use the base station log to correct this log, and then you can get very accurate positions. And so I'm going to show how to do a really basic thing to collect points on the ground for things like drone photogrammetry or just getting accurate positions of things. So the first thing I'm going to do is turn on this receiver by holding the power button, and then the screen goes on and it shows a little bit of information like the battery life, stuff like that. You're going to hit power, the same power button, until it says config. So it's going to basically go through the menu, and you're going to, once it hits config, you stop pressing the button, and then it shows SSID RTK config, and it shows an IP address. So then I'm going to take, I can put this down now. I'm going to screen record my iPad so you can see what I'm doing. So I'm going to 3, 2, 1. Okay, it should be screen recording now. Okay, so I'm going to start my, and maybe it'll be easier to sync up if I hold it up like this. I'm going to open my settings, and then I'm going to go to Wi-Fi. And I'm going to join that, which is RTK config. So I'm going to connect to that network. And I don't think it has a password. Yeah, it's unsecured. And then it pops up with the browser. And then I can hit the button or the link to go to the config. And there it is. That's the RTK Wi-Fi setup screen. So then I have to make sure my options are set how I need them. So I'm going to go to, first of all, GNS configuration, go to message rates. It's hard to find, but message rates, it's just a drop down and it expands out, gives you more options. So there are two buttons at the top: reset to surveying defaults and reset to logging defaults. Surveying defaults just gives you a position. That's not what we need. We need logging. We need actual logging. And in my opinion, it should always be set to log, because that's... Anyway, I'm going to hit reset to logging defaults. And then I'm going to scroll down. It shows you what it's doing. I don't know what most of these mean. Very bottom, hit save configuration. And then it says all saved. So it's good. The configuration is saved. What I'm going to do is turn it off. Like I'm starting from scratch basically. And it has my options set. Remember, we set it to logging. And then I'm going to put it on what I want to survey. Or not survey, I guess you can't use that word, but what I want to collect the position of. So I just want to get this curb right there. So I'm going to put it exactly in the center of that. Place it precisely. And then carefully so you don't move it, turn it on, and it should start logging within like a few seconds. I think is it on? No, I didn't hold the button long enough, so. Okay. So, is it on? Yes. So it's on, and within a couple seconds it should start logging. So I'm just going to leave it here for like 15 minutes, maybe 30 minutes. And then I'm going to come back, turn it off, and then grab it. Alright, so this Facet has been collecting data for a while. So now I can turn it off, and that will stop the log. I'm going to turn it off, and that's going to stop the log. So let me just be very careful not to move it. I should have been more careful than that, but anyway, turn it off. And yep, now it's off. So then I'm just going to take the SD card out of it, make sure it's off. Yes, off. So I just need to take the SD card, and that's going to have my log on it. But this height, the height of the between the ground and the base of this is very important, and then it has a little label on it that tells you, it's on the back side of it, it tells you the height between the base of the unit and where the antennas are, and it's dual band L1, L2, so it actually has two antennas, but they're pretty close because they're just stacked on top of each other. They're both flat, like hexagons. So anyway, the 2.5 centimeter, very important, approximately 1 inch. Or if you have a pole, you need to know the exact length of the pole. You know, if you adjust the pole and you forget to measure it before you do that, then it's like too late. So make sure you know your height of your pole or whatever, tripod, whatever it is. So I am gonna demonstrate how to make sure your Sparkfun RTK is actually logging to the micro SD card. And so the micro SD, first of all, goes in this slot under this flap. So, okay, SD card is in there securely. I think I formatted it on the computer using exFAT, just the standard option in Windows. Stuck it in, and I'm going to turn it on. Power button, hold it down, and then I'm going to screen record my iPad. I only have two hands, so I can't. Let's see. Screen record 3, 2, 1. Just switch this to config mode. So I'm going to hit the power button until the display shows config, and then, okay, now it's, I don't know if this is going to be visible, but it says RTK config. So then I'm going to, it shows up on my Wi-Fi list on my iPad, so I'm going to connect to it, and then it shows the login to captive. You might have to open up your browser. So let's see. It should be logging through the SD card automatically, but I'm going to make sure the settings are all right. I'm just going to go through all of them. And of course, login defaults that I set before. Here's the important option, log to SD card. The default is enabled, so you should be fine, but it shows there a log file name, and so it seems to be working. And you can always start a new log on here too, and open up File Manager, and it shows SD card information, so that's how you know it's actually working. I'm going to save my configuration. It says success saving. I don't know if that means it actually did succeed, but So I'm not sure if that means it saved my settings. I'm gonna exit and reset and see what happens. Is it actually rebooting? Well, so if there's any question, just switch it off by holding down the power button. It'll shut down and turn it on and do that whole thing again. These things can be a little bit glitchy, so if you're not sure, just start from scratch. Make sure your options are set right. It should be good. The next step after you collect your logs is to actually get them off of the SD card and do your post-processing. So I've got my SD card on my left Explorer window, and I have the folder where I put everything on my right window. So I'm going to make a new folder. I'm just going to call it June 02. 2nd of June is today. Open that folder, and then I'm going to drag and drop the file that I made today. So I'm going to drag that UBX file, and now I have it in my folder. And what is really important is what this file actually says in the name. So it's named according to the device, the Facet, Sparkfun something Facet, Sparkfun Electronics, I guess. And then 24 is the year, 06 is the month, 03 is the date. So this is actually, the date is tomorrow because it's UTC time, which is the same as GMT time. So it's 10 hours ahead of my time here in Hawaii. But this is all based on UTC. So created at 2 a.m. UTC, no, 2:40 a.m. And that's important because what you then have to do once you have this is get the correction file. So I am gonna open up Firefox, and I'm gonna go to cores. Here's the website, geodesy.noaa.gov/uf-cores. And so you can Google, if you Google user-friendly cores, you'll find this website. If you just Google cores, there's a lot of other older websites that may not be what you want. Just do a search for user-friendly cores. Okay, so start date. I'm going to use the UTC time because I have that from the file name. And then I'm going to choose the start time. Remember, it was 2:41 a.m., so I'm going to set my start time here at 2 a.m. It goes by hours, so that's what you choose your start time on the hour, and then UTC. You can also choose your time zone if you want to do it that way, but UTC, and then I think I had left it collecting data for like 15 minutes, but no matter what, it was less than an hour. So I'm just going to collect 1 hour worth of data, and then I have to choose my site. So I'm going to right click on this link to open the map in a new tab. I'm going to go to the map, click OK on the splash screen. This is all the core stations, so they exist actually all over the world. And so I'm going to go to where I am on Maui, zoom in, and there's a couple stations, Haleakala. One of them is Hal 1 and one of them is Maui. So let's see, the Maui one, it's operational now. For a long time it was non-operational, so you had no choice. So you can see some information about that, and then you can click on the other one and get information on that. So let's try the Maui one because I've never tried it before. So click that, and then or no, you don't need to, because I know it's operational. That's all I was really checking, which ones are available. So I just need to go back to that tab, and then I'm gonna choose Site Maui. and then I'm gonna choose GPS. This one doesn't have the GLONASS stuff available, so the correction is not going to be as good as the other one, I guess. So you know what? Let me switch to Haleakala. There's HAL 1, and see, that lets me choose GPS and GLONASS and Galileo and Beidou, which I think is the Chinese one. And so basically the more satellites you use, the better. So I'm going to choose the metadata because I want to get all of that, and click this button, get cores data file, and then I'm going to do save as, and I'm going to save it into my folder here. And if I go back to Explorer, there it is. There's my UBX file and the Haleakala. So now I just need to unzip this Haleakala. I'll just do extract all, and there, these files are, I can close this though. They're in this subfolder. So that's the base log. And so what we're going to do is take this base log, use it to correct my log. So I'm going to run mlid studio, which is a program created by this company mlid for their units, but it works on everyone's units, which is nice. So I'm going to go here, I'm going to grab this UBX file, and your option you would choose, because we just collected points, or just one point with the unit in one position for the entire log. I wasn't walking around or anything. That's static data. So I'm going to do a static correction. And so I'm going to go back to my folder, take that UBX file, drag it to the static receiver, and you see it says ublocks. So we'll accept the ublocks. Antenna height, very important. So this is 2.5 centimeters, and then the distance from there to the actual antenna within the unit, I don't know if this is visible, within the unit is 60 millimeters. So that's basically 25 millimeters plus 60 millimeters. That comes out to 85 millimeters. So my antenna height, I have to hit edit, and then use antenna height has to be selected, and then 0.085 meters, and that's the same as 85 millimeters. So that is set. And then the base station, I will go to the Haleakala folder, and I think it's the O file. Yes, I'll drag that 24 O file to base, and see, it fills in information. It knows that this is a Rhinex format file, and so it reads in the position of that base station. And before I forget, let me go back to this thing, and there's a readme with some information, and there's a coordinate. Okay, this is very important. The position of the base station is in this file, and it tells you the coordinate system. So it's NAD83 PA11, which is the Pacific plate. And because of plate tectonics, out here in Hawaii, we use this PA11 coordinate system that compensates for the tectonic plates moving. And so this is very important. NAD83 PA11 is what the format of this position is in, and this is all the information. Let's see if it's the same. I think that's right. This is in decimal degrees. This is in degrees, minutes, and seconds. The meters is the same. So this is all good. And we know the coordinate system. Now, remember that coordinate system, because mlid Studio doesn't understand coordinate systems. It's going to assume WGS 84. And So it's reading N8083 PA11 coordinates, but it's assuming WGS84, and that creates an offset. But overall, it kind of balances out. You know, the base, you're supposed to know the precise position, and so an offset is, in theory, not good, but in practice, it just offsets everything, and it's kind of okay, as long as you know that and compensate for it. So let me go into my options. I'm going to hit this gear icon, and then so you can see it's telling you what the start and end time is. And so remember, when I was grabbing it, it kind of wiggled a little bit. So let's say I want to get rid of that wiggle. I can change the time that I'm processing. So instead of going from this 242.20 to 307.29, I'm gonna make that 307.00. So it's gonna end before I grabbed it and moved it. And let's say, so when I put it down and set it up, I was kind of blocking the signal because I was standing too close, right? So let me adjust this one too. I'm gonna add a couple minutes, make it so go from 245 to 307. And that's UTC time. Okay, so my output solution, I'm going to choose all solutions because it's a log with 4 data collections every second, and so it's going to show us all that data. And the filter type, by default, it's forward. I set it to combined, and I'm not sure what that means, but I seem to get better results with combined. And then pretty much everything else you can kind of leave alone. Because it was static in one place, I used the fix and hold. And then for GLONASS, fix and hold. BDS, it doesn't give you an option. Elevation mask, very important, because that basically, because the system knows where the satellites are in space, in orbit, it can filter out ones that are below a certain degrees, like your angle toward the sky. So like 45 degrees is like that, 22 degrees is like that. So if you want to filter out things that are kind of behind trees or behind vegetation, you can use this. And I'm actually going to increase this to 30 degrees because there are buildings around and I want to try to filter out those buildings. I should probably go more than that, but we'll try 30 and see what the results look like. And scroll down. Time format, very important, UTC, because that's going to be consistent with pretty much everything else. So if you need to line up data with other things like photos off of I don't know, a drone or LiDAR data, anything, it's always going to be in UTC, I think. So choose UTC. And for your latitude, longitude, I always use decimal degrees. And that's it. Save. And then process. And there it goes. Wow, that's an interesting result. So basically float is better than single, and then fix is really good. And I won't go into details. There's a lot of math I don't really understand myself, the formulas, but basically float is pretty good, single is not good. So we've got, this is a log over, 20 something minutes, 22 minutes. And it looks like in the beginning, there is all these coordinates. And then at some point, the signal got much better and you got this tight cluster down here. So that's kind of interesting. Let's see, 44 meters, 47 meters. So this is a pretty big gap. This is several meters. This is like 3 meters difference between these two clusters, but these look like more accurate. So And it's probably like this because I was between tall buildings, so the signals will bounce, and then when they bounce, that creates like a false position basically. So I'm not surprised that the system got confused, but this is just a demonstration. So let me go on to the next step. I'm going to hit the gear again, and I'm going to switch it from all solutions to one best, and then I'm going to process. Okay, so it's done its magic and it shows 1 point that it thinks is accurate. And if you remember, the height of that cluster to the southeast, the orange ones were 44 meters, and this is 44. So it looks like it grabbed those orange ones, averaged them together kind of, maybe did some more math than that behind the scenes, and this is the result. So with that coordinate, you can just do a copy. You can hit copy and you can get that. And then you can, if you open Notepad or something, you can just do like a, why is my Notepad not working? Try Sublime Text Editor. Control Paste or Control V, and there, you can use that. But you can also hit Show Result Files, and then make sure you sort by date so that the newest files are at the bottom. And you see these POS files. These are basically what you generate. And so I think the last POS is going to be, if I open with, or I can drag and drop into Sublime. Yes. So can I zoom in? Yeah. So you got the latitude, the longitude, and this actually has more digits. See, this went up to 5.8, and then this is 5.84, so it's more precise, slightly more precise. So I would always use this file rather than just copying from the program. And then that's it. That's how you get your precise coordinates. If you're using a program like Agisoft, you can put this in as a ground control point, just like that. It's a little bit tedious to be typing these numbers in or whatever, but you can just use this. You don't need to use GIS programs. But just to show, I'm going to open up ArcGIS. Alright, so I've got my ArcGIS Pro project. I'm going to hit on the Map tab, go to XY, and this pop-up is going to appear down here. It's easy to miss, but I'm going to take my coordinates off of that text file. So Sublime Text Editor, that's the longitude. Let me see if I can make that more clear. Yeah, because I zoomed in, it kind of messed up the, so that 20 degrees is the latitude. That's your up and down, north and south, I mean. Paste that into there. I'm going to take the longitude and paste that into there. And I can flash the point, and I can zoom in, I can flash the point again. And here's what I can do. I can choose a few different options. I'm going to use this push pin. Yeah, the push pin. And it should, if I click that, there. So it has placed a push pin. I think that's, there's my image. So that's the coordinate I'm getting. That's my drone orthomosaic, which is much newer than the satellite photo. And so that's pretty close, about a meter difference. Now, but here's the thing. What coordinate system am I in? I'm in the wrong coordinate system, see? So I needed to be in N8083 PA11. So if I switch to that coordinate system, so I've switched to that to the proper coordinate system. Now I'm going to try entering my coordinates again. Oh, I was missing a digit too. There's a 4 on the end of that. And then I'm going to grab this latitude and look at that. See, it's so there. You have a real-time demonstration of what the difference is between NAD83 and PA11. Same coordinates, but when I switch my project by going to properties and then choosing the coordinate system, that lets me, when I put in a coordinate here, it reads it as the proper coordinate system, NAD83 PA11. And so we can measure what the difference is. It's about 2 meters. 2 meters offset. And then if I want to measure to that point, about 1 meter, so it's about a meter off from my drone orthomosaic, so it's pretty good. And then of course you can do whatever you want with your coordinates. Just make sure it's the right coordinate system. One more thing to note is, so in your folder, Emlet Studio generates a new folder, and that's the Rhinex version of the UBX file. So it converts the UBX to Rhinex, and so those are like standard format. So you can share these logs, this log with someone along with the other data, and they can do their own corrections, whatever. So always good to archive these things and also keep the original UBX file. You never want to throw away this kind of data because it can always be corrected better after the fact. Maybe you want to try a different base station or more advanced methods. The technology is probably going to keep advancing, and who knows what's going to be possible in the future. Maybe AI is going to let us do super accurate corrections. I don't know. But always keep your original data. It's like when you take photos, you keep the raw files. You don't throw them away just because you're done editing. 'Cause you don't know how things are going to change in the future. So always keep that stuff. Files aren't huge, just save them. Hopefully this was helpful.